Notes. High School Math 1, 1-7, or 1-6, or something like that. This is my trick for finding missing terms in an arithmetic sequence. What's arithmetic? Oops. Addition and subtraction, exactly. You haven't forgotten, have you? Yeah, that's your addition and subtraction. So, if you have a problem like this, 2 with a space and a space and a space and a 14, you kind of have to be told whether it's multiplying that'll get you there or adding or subtracting that'll get you there. In this case, it's arithmetic, so it's going to be adding or subtracting. And you could kind of do a guess and check to get the answer on this. But there's an easier way. There's an easier way. It works like this. Take the rightmost number of the spaces. If there's another number, you take this one because it's closest to the space, right? You take the rightmost number, you subtract the leftmost number. This guy. And you divide that by the number of spaces between them plus 1. You have to get that plus 1 in there, otherwise you'll get it all whacked out. So in this problem, like I said, you could kind of do some guessing and checking, but we have 14 minus 2. That's my right number minus my left. Divided by the number of spaces between, that's 3 plus 1. So this is going to give me 12 divided by 4, which is 3. Now that's the what's going on. That's the number that you are going to add to get to the next digit. So let's see if it works out. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. And 11 plus 3, do we get to 14? There it is. There it is. This is the constant difference, or the what's going on. I like what's going on, but constant difference is what you'll read in the book because, well, all that highly educated wordy stuff, right? All right, the other thing I want to talk about briefly, because we're starting to get into it, is order of operations. And there's a common way that most teachers teach the order of operations. Has anybody run across that? Yes? PEMDAS, right. Please excuse my dear Aunt Sally. So PEMDAS is a way of helping us remember the order of operations, which is critical in math. The P stands for parentheses. And that's what you always have to do first. You do what's inside the parentheses first, or sometimes we do distributive property if we have to. I always wait, see if only if I have to. The next thing is exponents. It also includes radicals, square roots, and things like that. Then multiplication, division, divide, add, and subtract. Does anybody know some additional detail that we need to add to this? Because if you do it just like this, That's correct. They are together. And do you know what order we have to do them in on a particular problem? Left to right. Yeah, left to right. So these have to be done left to right. The same is true for the add and subtract. Okay, left to right. Now, as long as you keep these in mind, you're good. And I've got no problem with remembering it as PEMDAS. But that's not my way. So for those of you that maybe struggle with this whole PEMDAS thing, let me show you my way. I actually don't like this. But it works for some. And I'm not trying to talk you out of it if it works for you. Here's how I order them. This is Mr. T's way. If you'll figure out, I've got some different ways of doing things. Although I've seen this online too, so I'm not the only one that came up with it. Number 1, number 2, number 3, and number 4. There are only 4 orders of operation in my book. The first one, and I'm very visual, so I think in terms of pictures. Sometimes I can't come up with a word. I got the picture in my head, but I can't tell you. Thinking of a car, it's a Camaro. I don't know, or something like that. Okay, I can't think, but I can come up with pictures. It's not just parentheses, it's any kind of grouping symbols or brackets. That's one of the things I don't like about order of operations, is it's kind of incomplete in that definition. The next thing, exponents. Oh, how about we say z to the x power or something like that. Exponents. You have to deal with exponents. And you won't really have to deal with this much in this class, well, maybe second semester a little bit, but also radicals, right? Exponents and radicals. They have to be taken care of second. No radicals mentioned in this. And a radical is kind of like, you know how multiplication and division have a relationship? Radicals and exponents have the same relationship. The next thing is multiplication and division. But I put a little arrow here to remind me that it's left to right, because it could be division before multiplication, depends on the problem. And the fourth thing is your addition and subtraction from left to right. This is the way I think of it, and how I keep track of it. But again, I'm more visual, less like wordy. You're probably not going to have, like, I don't remember names by association and stuff like that much. It takes me a long time to get names down because I don't really have any of those neat little tricks that some of the other teachers do. If you guys all went by numbers, I'd probably have an easier time remembering that, or pictures. Remember when Prince? No, you don't. You're too young. Remember the artist Prince? For a while, he went by this weird symbol that nobody could pronounce because there was no pronunciation for it. Yeah, so I'd probably be pretty good with symbols. All right, that's it for notes today. Let's look at the assignment. So I think I said, yeah, we're going to skip the task today. Yay! Yay! The crowd bursts into cheers. Yay! Oh, well. Don't work ahead. There's your lesson. Okay. So let's look at a couple problems here. Let me see, what did I do with first period? Let's see, first period we did 1 and 2. You don't really need my filling in the blank trick here because we've got numbers that are next to one another. We can figure out what's going on here pretty easily, I think. You don't have like multiple spaces between values. Wants us to identify the common difference or ratio, say what it is, and say whether it's arithmetic or, arithmetic or geometric. So, what's the pattern here? 5, 25, 30, 35. So the common, is that a common difference or a common ratio? Is it arithmetic or geometric? It's arithmetic, so it's a common difference. It's a difference. How do you get from one to the other? You can subtract. 10 minus 5 gives you the 5. 15 minus 5 gives you the 5. It's the same 5 for each one of them. Now, is that arithmetic or geometric? You already answered that question. It's arithmetic. Anytime you're adding or subtracting, it's arithmetic, and it's a common difference. Look at number 2. 20, 10, blank, 2.5. Am I adding or subtracting or? Divide by 2. Good, good. What's another way of saying divide by 2? Multiply by 0.5, that's one way. Multiply by, or I prefer multiply by 1/2. This is the one I'm going to use, okay? But these are all true. They all work. This is your best choice, okay? Good job. So I'm going to say that this is times 1/2. Is that a difference or a ratio? That's the ratio. And is that arithmetic or geometric? Geometric. The multiplication means it's going to make a curve. It's going to make a curve. Okay. Think you got that? Let's look at 5 and 6. Determine whether the given information represents an arithmetic or geometric sequence. Then write the recursive and the explicit equation for each. Okay. 2, 4, 6, 8. Who do we? Oh no, wait, that's something else. Right. Okay. Is that arithmetic or geometric? Arithmetic. Good. We're adding, right? How about let's add this? The what's going on? Plus 2. I buy it. So what we need is we need the what's going on and we need the first starting point for both of these. The problem is it doesn't tell us that much. It says that the output is 2, but what's the input? Yeah?
2.
It could be. We kind of get to pick, but I don't. If I were picking, I wouldn't pick 2. 0? If it were me picking, I'd pick either 0 or 1. Either we're going to say this is 0, 1, 2, 3, or 1, 2, 3, 4. I don't really care. I don't think starting at 2 makes. I wouldn't. You could, but I wouldn't. I heard 0. Let's go with 0. Okay? So 0, 1, 2, 3. So the recursive is going to look like this. What's f of x? It's the current term. It's the thing we're looking for. It's
2.
not yet. Equals the previous term. What do I have to do to the previous term to get to this term? I have to add 2 to it. Yes?
I was saying like have 2 as a starting point on the where it says 2.
Oh, I see.
Yeah,
That's true.
I had it as 0, 1, 2, 3, 4.
Oh, did you? Oh, so then we're good. Okay, we're good. That's what I was getting at is what term is it, right? And you're saying what the output is. That's all. We're on the same page. Okay, now, I haven't graded your guys' quizzes yet, obviously, but I just graded first periods before you walked in. And you know what they forgot the most or don't understand the most?
Explicit.
No, it didn't. The quiz didn't ask for the explicit. It only asked for the recursive. Nobody understood what the starting point, how to write the starting point. That is the starting point. So we say f of 0 equals 2. F of 0 equals 2. Okay. F of 0 equals 2. That's why I circled that. That's necessary. None of the other ones really are. Okay. Explicit. The next output, or the output that we're looking for, we got to start with the what's going on, plus 2. But I don't need to write the plus. I'm just going to put the 2. How many times am I going to add 2? Yeah, I don't know. How many times as I want, right?
But they get Billy Joel. I didn't get Billy Joel when I was big.
I know, that's crazy. Maybe you will tomorrow, I don't know. First I've heard it today.
Yeah.
Now, if I put in 0 here, do I get 2 for an answer? You have to check it to see if you need to make an adjustment. Is 2 times 0 equal to 2? This 0 is that one, this 2 is that one, and this is the what's going on. Is that true? No. So I have to do what to make this true? Add 2. Yeah, plus 2. So if I have to do it here, I've also got to do it here. And what you can do is now plug in another number. If you plug in 2, do you get 6? 2 times 2 is 4, plus 2 is 6. Yeah, it works. Right? If I plug in 3, 2 times 3 is 6, plus 2 is 8. That way you can kind of check yourself. When it's arithmetic, your adjustment can be adding or subtracting. If it's geometric, it cannot be adding or subtracting. It has to be multiplying. So let's look at this one. 2, 4, 8, 16. What's going on? That's right. We're multiplying. We're doubling. We're multiplying by 2, right? Doubling. Now, I need a starting spot. Do I call this 0, 1, 100? What do you think? I'd say 0 or 1. 0? Okay. You have to be able to do it with zeros and ones. Pretty much you have to, because some problems force you to use ones, other problems force you to use zeros. If you get to pick, I kind of like 0. You know why? You notice these 2's are the same? That becomes your y-intercept. Your adjustment will be that if your input is 0 every time. Okay? Okay, so recursive, f of x equals f of x minus 1. The now equals the previous. What do I have to do to the previous to get to the now? Multiply by 2. That's right. And I have to say where that pattern starts. F of 0 equals 2. When x is 0, the output is 2.
Determine 0 or 1.
You get to pick. Yeah, you get to pick. If you pick 1, it'd be fine. Our explicits will look a little different. But as long as if you plug in the other values, you get the same answer, we're good. Okay. Yeah. Yes?
For example, if the f of x equal to the x power,
We do.
the adjustment should be times 2, because 2 equals 2 to the 0 power times 2.
I believe you're right. I believe you're right. So, if I plug in, okay, so this is absolutely correct. We don't know how many times we're going to multiply by 2, as many as we want. But if I plug in that 0, I have to get 2, because when x is 0, y is 2, or the output is 2. But 2 to the 0 power is 1. Any number to the 0 power is 1. Don't forget it. So I've got to multiply that times 2 to make that true. Now let's check one of the others. I got a calculator here. Let's check this out real quick. If I go, let's say I plug in 3. Let's see if I get 16. If I go 2 and I raise that to the 3rd power, I'm plugging in the 3. I should get 16. But I don't. I get 8. Oh, that's right, because I forgot. I've got to multiply that times 2. Right? That's the adjustment. And then it works. Okay. If you add or subtract, it'll work once, but it won't work for any of the other terms. Okay. All right. I think that is all I wanted to say. I've talked enough up here.